Hi, I'm Jonathan Wieland from the HCI group at the University of Konstanz, and together with Rudolf Hegemann, I'll present our paper Arrow, Bézier Curve or Halos, in which we compare different 3D out-of-view object visualization techniques for handheld augmented reality. And we do this on behalf of our co-authors, who are Harald Reiterer and Tiare Feuchtner. One of our ongoing research topics are mixed reality supported interactive exhibitions, which we also explore in the wild by making them available to the public. And what you see here is our latest exhibition, which was entirely based on handheld augmented reality. So as you can see in the picture on the right, visitors were equipped with a tablet that allowed them to explore different AR-based exhibits on the topic of pandemics. However, one limiting factor here was the limited field of view of the tablet camera, which required visitors to carefully scan their surroundings and also made them miss out on interesting content. One way to improve the discoverability of content are off-screen or out-of-view visualizations. And as you can see here, for example, related work has used two-dimensional halos and arrows to visualize the position of the out-of-view objects. However, the problem with such 2D visualizations is that they often lack information about the direction and the distance of the out-of-view objects. So, for example, if we would use a simple arrow here in the example of our exhibition, then it could basically point to any of the positions highlighted in the top-down view here on the right. So basically to any position that is located on the right of the user, which of course again increases the effort for searching. To address this, a number of techniques have been introduced that utilize 3D proxies for guiding users to the out-of-view objects, as arrows, curves, and also halos. However, most of these works studied head-mounted displays and virtual environments, and these of course differ strongly from handheld AR displays in terms of stereoscopic vision and also ergonomics. The few works that did explore handheld AR so far only focused on 3D arrows as proxies. With our work, we aim to expand on this by exploring these three different types of 3D proxies for handheld AR displays and also evaluate them in comparison. Consequently, our first visualization relies on a 3D arrow, as you can see here in the video. And the arrow always hovers at the same position in the user's view and points towards the out-of-view object. To additionally also encode the object's distance, we implemented a color coding. Here we use a warm-cold analogy, so if the object is far away, then the proxy is colored in blue, and for indicating close objects, its color changes through white to red. Our second visualization uses a Bézier curve to guide the user to the out-of-view object, again relying on the same color coding. So if the target is near, then the curve is colored in red, and if it's further away, then the curve is first colored in white and then in blue. And our third visualization relies on pulsing 3D halos. Here we utilize the metaphor of a stone thrown into the water. The halos constantly originate from the position of the current target and then move towards the user's view like ripples on the water's surface. And as for the other two visualizations, we again use the same color coding for distance. To evaluate our visualizations, we followed a two-step evaluation process. So first we conducted an exploratory case study followed by a controlled lab study. The case study took place directly in the exhibition shown before, and here our aim was to explore the applicability of our visualizations in this real-world scenario and also to gather feedback to further refine our visualizations. So during the exhibition, we invited 6 visitors to use our visualizations for locating 5 AR-based interactive exhibits. And in a concluding interview, all participants agreed with the applicability of the visualizations in the exhibition context. And they especially valued that the visualizations were helpful to find the exhibits and also to avoid overlooking them. Based on participants' feedback, we then further refined our visualizations and conducted a controlled lab study with 24 participants to compare them in terms of performance, workload, and user experience. And in this talk, we'll focus on performance and user experience results as differences regarding workload were minimal. And of course, we invite you to read the paper for further details.
During the study, participants had to perform two tasks, a search task and an estimation task. The search task was always performed first. Here, participants had to sequentially locate 20 spheres that were distributed throughout our labs, as you can see in the video. We instructed participants to solve this task as quickly as possible and measured their performance based on task completion time. And as you can see in the plot, participants were fastest using 3D arrow, followed by 3D Bézier curve. Surprisingly, they were slowest with 3D halos. Additionally, we measured the overall rotations participants needed to find all spheres, assuming that target-directed movements involve fewer changes of direction. Here we have a quite similar picture. Again, participants performed worst using 3D halo. However, here 3D arrow and 3D Bézier curve were comparable. After the search task, participants performed the estimation task, which involved looking at the visualization and guessing the position it indicates. For that, the visualization was only shown while facing away from the target. Once they turned around, a virtual sphere appeared which they needed to place at the estimated position. For each visualization, this was repeated 10 times for different positions distributed across our lab. To measure the performance during this task, we calculated the participants' estimation error. For that, we measured the Euclidean distance between participants' estimated position and the actual target position indicated by the visualization. As you can see, the results draw a similar picture as for the other performance-related measures. Again, there were no significant differences between 3D arrow and 3D Bézier curve, and participants performed significantly worse using 3D halo. At the end of both tasks, we assessed the user experience of our visualizations via the user experience questionnaire and the semi-structured concluding interview. Here on the slide, we have the results of the user experience questionnaire. Unsurprisingly, the novelty of 3D arrow was not very high and scored significantly worse than 3D Bézier curve and 3D halo. What we consider as more important are the dimensions perspicuity, efficiency, and dependability. Here, in line with the performance-related measures, there is a tendency that 3D arrow was scored better than the other two visualizations. The statements participants made during the concluding interview provide further insights regarding the differences in performance and user experience. 3D arrow, for example, was mainly valued for its simplicity and described as clear, simple, and intuitive. But on the other hand, participants also said that it only provides rough directions. In contrast to that, 3D Bézier curve was valued for visualizing the out-of-view objects' positions very clearly and for having a guiding character. However, participants also perceived it as overloaded, which indicates that future work should further refine the design of this visualization. For 3D halo, participants mainly valued, in addition to the color coding, the curvature of the arcs also conveyed the distance to a target. However, they criticized that the halos took some time to become visible on the screen, which again indicates room for improvement in the visual design of the cues. Our results allow us to draw conclusions on which visualization should be used in a handheld scenario. In terms of applicability, in the real-world context of an exhibition, we could show that all three visualizations are applicable and helpful in finding the interactive exhibits. The overall results of our subsequently conducted lab study indicate that traditional 3D arrow is the best choice in terms of performance and user experience. However, they also revealed 3D Bézier curve as an effective alternative which could be further improved with design refinements. In particular, it could be promising for directing users around obstacles due to its guiding character, which could be further explored by future work. With this, we hope to inform the design of 3D out-of-view object visualizations for handheld AR displays and inspire more research on this topic. And for more details on our work, please refer to our paper. Thank you.